Welcome to all for this today's session. Today we are going to discuss about the aerodynamic forces and moments in the subject called aerodynamics. This is the first topic in first unit. Basically, in an aircraft, four forces called thrust, drag, then self-weight of the aircraft, and another one is lift. These four are very important forces called aerodynamic forces here. Let's come to the point. A force may be thought of a push or pull in specific direction. And a force is a vector quantity. So a force has both magnitude and a direction. When describing forces, we have to specify both the magnitude and the direction. This slide shows the forces that act on an airplane in flight. Let's come to the point for weight. Weight is a force that is always directed toward the center of the earth. The magnitude of the weight depends on the mass of all the airplane parts plus the amount of fuel plus any payload on board. That means people, baggage, freight, and etc. The weight is distributed throughout the airplane, but we can often think of it as collected and acting through a single point called the center of gravity. In flight, the airplane rotates about the center of gravity. Flying encompasses two major problems: overcoming the weight of an object by some opposing force and controlling the object in flight. Both of these problems are related to the object's weight and the location of the center of gravity. During a flight, an airplane's weight constantly changes as the aircraft consumes fuel. The distribution of the weight and the center of gravity also changes. So the pilot must constantly adjust the controls to keep the airplane balanced. So this is about the self-weight of the aircraft or an airplane. And next, the second aerodynamic force, we are going to talk about lift. To overcome the weight of the aircraft, an airplane generates an opposing force called lift. Generally, weight is acting toward the center of the earth, that means towards downward direction. So lift is opposite direction, so it will move in the upward force. That is called opposing force called a lift here. So lift is generated by the motion of an airplane through the air and is an aerodynamic force. Aero stands for the air and dynamic denotes motion. Lift is directed perpendicular to the flight direction. The magnitude of the lift depends on several factors, including the shape, size, and velocity of the aircraft. As with weight, each part of the aircraft contributes to the aircraft lift force. Most of the lift is generated by the wings. Aircraft lift acts through a single point called center of pressure. So it's a very important point called center of pressure, in which the aircraft lift acts through a single point. That point is called the center of pressure. And the center of pressure is defined just like the center of gravity, but using the pressure distribution around the body instead of the weight distribution. The distribution of lift around the aircraft is important for solving the control problem. The aerodynamic surfaces are used to control the aircraft in roll, pitch, and yaw. Generally, these are called primary control surfaces, which are being controlled these kind of moments. The next aerodynamic force we are going to look on is drag. As the airplane moves through the air, there is another aerodynamic force being present. The air resists the motion of the aircraft, and the resistance force is called drag. Drag is directed along the opposed to the flight direction. Like lift, there are many factors that affect the magnitude of the drag force, including the shape of the aircraft, the thickness of the air, and the velocity of the aircraft. Like lift, we collect all of the individual components and drags and combine them into a single aircraft drag magnitude. And like lift, drag acts through the aircraft center of pressure. So this is about drag. So a lot of drag force are also there. We will look on those types of drag in the next for coming classes. And then another aerodynamic forces we have to look on is thrust. To overcome the drag, airplanes use a propulsion system to generate force called thrust. The direction of the thrust force depends on how the engines are attached to the aircraft. In the figure shown above, two turbine engines are located under the wings, parallel to the body, with thrust acting along the body center line. On some aircraft, such as Harrier, the thrust direction can be varied to help the airplane take off in a very short distance. The magnitude of the thrust depends on many factors associated with the propulsion system, including the type of engine, the number of engines, and the throttle setting. For jet engines, it is often confusing to remember that the aircraft thrust is a reaction to the hot gas rushing out of the nozzle. That means in the nozzle, the flow of air or any gas will be higher at the outlet. That is the function of the nozzle to increase the velocity. Here, the hot gas goes out the back, but the thrust pushes towards the front. This is the reflection of the Newton's tail of reaction. Each and every action has its equal and opposite reactions. Accordingly, the hot gases goes out the back side, but the thrust pushes towards the front side. The motion of the airplane, through the air depends on the relative strength and the direction of the forces shown above. If the forces are balanced, the aircraft cruises at a constant velocity. If the forces are unbalanced, the aircraft accelerates in the direction of the largest force. So this is about the another aerodynamic force called thrust. Then aerodynamic moments. So we have three moments are there. That is pitching moment, rolling moment, and yawing moment. These moments are being controlled by primary control surfaces, and they are the very important surfaces are attached with the aircraft bodies, which controls the moments of the aircraft. The aileron is a primary control surface which is responsible for the rolling moment. But for pitching moment, it means the nose up and down. It will be taken care by it is a elevator. Okay, the nose up and down. So that motion is called pitching motion. So the moment is produced is called a pitching moment. So elevator is a primary control surface which is responsible for this pitching moment. Another one is called yawing moment. Yawing moment is as a direction change. Okay, so it is being controlled by the rudder. So rudder is the responsible primary control surface which is responsible for the yawing moment. So in today's class, we have discussed, once again, I am summarizing here. So there are four aerodynamic forces are there. One is weight, lift, drag, thrust. Okay. And how thrust is produced and what is the opposite forces as well as the self weight of the aircraft. What about the lift? So these things and all we have discussed here, and aerodynamic moments we have discussed. There are three aerodynamic moments called pitching, rolling, yawing. Okay. So that's all in today's class. We will see another topic with another PPT with different day. Okay. Thank you for your kind cooperation here. We will see you in the next class. Thank you.